All right, here's a problem from the packet, problem number 3. We have the sequence, and hopefully we can see very quickly that this is an arithmetic sequence. We can tell because the difference between consecutive terms is constant. So we take the latter term minus the previous term. We get a number, 17 in this case. We take the latter term minus the previous term, and we get the same number. So that's how we know it's an arithmetic sequence, where in this case the difference is 17. So the question says find the value of u sub 20. Well, we go ahead and grab one of our data booklets. And for arithmetic sequences, we have this formula given to us, where u sub n is equal to the first term plus n minus 1 times d. So for our example, the first term is 600. We're trying to find the 20th term. So 600 plus 20 minus 1 times the difference, which we found originally to be 17. So go ahead and plug that into our calculator. Uh, 19 times 17 plus 600. And we get 923. And that's our answer to the first part. It then says what is the sum of the first 10 numbers in the sequence, or first 10 terms in the sequence. And so that's using this formula right here, where S of n equals this or this. We can use two different formulas here, one that includes d or one that includes u sub n. Since we don't know what u sub 10 is, we'll go ahead and use this other one because we do know what d is. So for this, the formula would be S sub n, or in this case, n equals 10. So S sub 10 would be equal to n divided by 2, 10 divided by 2, times 2 times the first term, which is 600, plus n minus 1, that'd be 10 minus 1, times the difference, 17. We plug that into our calculator. I'll start on this side. 9 times 17 is this part, so I'm going to add to that 2 times 600, which is that, and then I'm going to multiply that by 10 and divide by 2, which is the same thing as multiplying by 5. So the first 10 terms, when added together, gives us 6,765. That was part B. Part C is a new sequence. We have a new sequence, and if we subtract these numbers, 6 minus 3 is 3, 12 minus 6 is 6. So this is not an arithmetic sequence, because the difference between consecutive terms is different. But it might be geometric. Geometric is we divide. So is 12 divided by 6, the latter term divided by the previous term, is that value constant? 6 divided by 3, yes. 24 divided by 12, yes. In this case, this means we have a geometric sequence where the common ratio is r. So we're going to be using these two formulas from our booklet. All right, so let's find the exact value of our 10th term. So v sub 10 would be equal to the first term times r to the n minus 1. The first term is 3 times r, which is 2, to the n minus 1, 10 minus 1. So that's 2 to the 9th power times 3, 1,536. That is our 10th term. And then it says here for part D, find the sum of the first 8 terms. And again, we have a different formula for sum. Sum of the first however many terms, in this case 8 terms. The sum of the first 8 terms for our geometric sequence is, and we have two formulas here. We can use either one. I'm just going to use this first one, where it's the first term. What is my first term? 3. My first term is 3 times the ratio 2 to the nth power, which is 8 minus 1. All of that divided by the ratio minus 1. So I plug that in my calculator. 2 to the 8th minus 1 times 3 divided by 1 is 765. And the last part of this, E, we don't have to do necessarily for this test. But it says, what is the smallest value for n for which v sub n is greater than u sub n? So v sub n, we have a formula for v sub n. It's right here, but we have to actually plug in the generic part of it. So the formula for v sub n would be 3 times 2 to the n minus 1. And the formula for u sub n, which was our previous sequence, is u sub 1, which was 600, plus n minus 1 times the difference, which is 17. So these are our two formulas. This is for v sub n, the geometric sequence. This is u sub n, arithmetic sequence. So it says, what is the smallest value for which the v term, what's the smallest n value for which this becomes bigger than this? And so we can actually set these equal to each other, or we can write an inequality. When does v sub n become bigger than u sub n? So we can plug this in to this equation. When is this bigger than this? And so one of the ways we can do this is, well, let's just find out when they're equal. If we find out when they're equal, then we just take the bigger number of n and say, well, that's the first value of n that it's actually bigger. So how do we do that? One of the ways we can do that is by using the numeric solver. So we go to math. It's the last one, so I can actually just scroll up, and it goes all the way down to the bottom, numeric solver. And here I plug in the two sides of my equation. On one side of my equation, I have the geometric term, 3 times 2 to the variable minus 1. And on the other one, I have my geometric sequence, 600 plus my variable x minus 1, all of that times 17. So I hit OK. It says, give me a guess. I'll guess, well, I'm not going to guess 0. Let's guess 8. And it finds out, we find out that it's not 8, but these two are equal to each other when n equals 8.94. So when n equals 8.94, these two terms are equal, but we know we can't have a term 8.94. So the next term would be n equals 9. You have to round up to the nearest whole number, n equals 9. That's the first term where this is going to be bigger than this, because 8.94 is when they're equal, so the next whole number up would be 9. That is the first term when v sub n is going to be bigger than u sub n. So v sub 9 is bigger than u sub 9. It says find k. Well, that's what it is. So k is the smallest n value. So in other words, when n equals 9 or k equals 9, that's our answer.